Today we're going to be talking about molecular geometry. Now, Lewis dot structures help us determine the number of bonds and lone pairs needed to determine the molecular shape and electron geometry of a molecule. The molecular shape is a 3D structure of the arrangement of atoms in a molecule, and the electron geometry is the arrangement of various electron groups. What I mean by electron groups is they can be lone pairs, or they can be single, double, or triple bonds that the center atom has. The use of valence shell electron pair repulsion, also known as VSEPR theory, is used to determine the molecular shape and the electron geometry of a Lewis dot structure. And the VSEPR shell electron pair repulsion theory, abbreviated as VSEPR theory, states that electron pairs repel each other whether or not they are in bonds or in lone pairs, so they would spread themselves as far from each other as possible to minimize repulsion. Okay, let's go ahead and do practice problems of molecular geometry. So for each of the following molecules, we're going to draw the Lewis dot structures, determine the number of bonded atoms and lone pairs in the center atom, and the molecular shape and the electron geometry. So first thing we're going to do is we're just going to go ahead and figure out what the Lewis dot structure is for problem number 1, and we have OF2. So we're just going to be reviewing Lewis dot structures, which is what we learned last time. So first thing we have to do when we do Lewis dot structures is find the total number of valence electrons. Oxygen has 6 valence electrons. There's only 1 of them. Fluorine has 7 valence electrons, and there are 2 of them, which brings our total number of valence electrons to 20. So now that we have our total, we can go ahead and start setting up our structures. So our arrangement, we know oxygen is going to be in the center because we only have 1 of them, and fluorine is going to be the outsides. Then we're going to go ahead and bond those 2 together. And making those 2 bonds, we used 4 valence electrons. So that means we have 16 valence electrons left over that we'll use for dots. And we start our surroundings first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And before we say this is our Lewis dot structure, we have to figure out if all of these elements follow our octet rule. And when we do look at our Lewis dot structure with their atoms, all of these have 8 valence electrons around it. So that is our Lewis dot structure for number 1. Now, based on Lewis dot structure, we can figure out how many bonded atoms and lone pairs we have. When we figure these out, we're only looking at our center atom. Our center atom is oxygen. So looking at oxygen, we only have 2 bonded atoms. We have 2 surrounding elements. And then again, looking at our oxygen, it has 2 lone pairs. We have a lone pair here, and we have a lone pair here. We're not going to worry about the lone pairs on fluorine because again, we only need to look at our center. So we have 2 lone pairs. Now we have to look at our VSEPR theory chart. Finding the row that says 2 bonded atoms and 2 lone pairs, our molecular shape is bent, and our electron geometry is tetrahedral. And that is our answer for problem number 1. So let's go ahead and move on to problem number 2. We're going to draw the Lewis dot structure for CO2. First thing we have to do is find the total number of valence electrons. Carbon has 4, and we only have 1 of them in the compound. Oxygen has 6, and we have 2 of them in the compound. So when we plug all of that in, we have 12, 13, 14, we have 16 valence electrons. So now that we know our number of valence electrons, we can go ahead and do our arrangement. Carbon's going to be in the center because we only have 1 of them, and our oxygen is going to be surrounding them. And let's go ahead and make those bonds to connect them. We made 2 bonds, therefore we used 4 valence electrons. So we have 12 valence electrons left over, which we're going to have to put 12 dots. We start with our surroundings first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And before we say this is our Lewis dot structure, we have to figure out if all of these elements follow our octet rule. Carbon does not. So we're going to have to move lone pairs to become new bonds. So you can take any of these lone pairs. I'm going to go ahead and take this one, and we're going to make that into a bond. Therefore, these go away. And carbon is still not happy. So we'll have to do it again. We can either make this double bond to a triple bond, or we can make two double bonds. It does not matter which direction you go. You're both going to get the same answer anyways. I'm going to go ahead and make another double bond. So I'm going to take these pairs and make it into another bond. Therefore, these go away. And now that carbon has 8 and both of the oxygens still have 8, that is our final answer. And now we can go ahead and figure out how many bonded atoms and lone pairs we have. Again, we look at our center only. Looking at carbon, we still only have 2 bonded atoms. You may want to say 4 because we're thinking bonded bonds. It's not asking how many bonds we have. It's how many atoms are bonded to it. We have 2 oxygens bonded to carbon. That means we have 2 bonded atoms. And for our lone pairs, again, we're only looking at our carbon. Our carbon does not have any dots, therefore we have 0 lone pairs. So looking at a Vesper theory chart, finding the row that has 2 bonded atoms and 0 lone pairs, it says that our molecular shape is linear, as well as our electron geometry is also linear. And that is your answer for problem number 2. So moving on to problem number 3, we have NH41+. We have to find the total number of valence electrons. So nitrogen has 5 valence electrons, and we have 1 of them. Hydrogen has 1 valence electron, and we have 2 of them. And this time we have a charge. That charge tells me that we are losing 1 valence electron, which will bring our final total to, we have 4 hydrogens, not 1 hydrogen, and that's going to bring our total to 8 valence electrons. So now that we know our total, we can go ahead and start arranging our atoms. Nitrogen is in the center because we only have 1 of them, and we have hydrogens. That's going to be around it. So now that we're going to go ahead and bond those together. We made 4 bonds. That means we used 8 valence electrons. Thus, we have no more valence electrons left over, so we are not going to have any dots. And looking for our octet rule, all of these elements are happy. Remember, hydrogen is an exception. It only wants 2, never wants any dots. So now that we're good with that, remember, when we have a charge, we need to make sure we put brackets and the charge around our compound. So now that we have our Lewis dot structure, we can go ahead and figure out how many bonded atoms and lone pairs a center atom has. So looking at our center atom, we actually have 4 hydrogens bonded to the nitrogen. That means we have 4 bonded atoms. Nitrogen has no dots, so we have 0 lone pairs. So looking at our Vesper theory chart for 4 bonded atoms and 0 lone pairs, both the molecular shape and the electron geometry is going to be tetrahedral. And tetrahedral again. And that is our final answer. All right, let's go ahead and do one more problem together. We have SO2. So first thing we got to do is valence electrons. Sulfur has 6 valence electrons. We have 1 of them. And oxygen has 6 valence electrons, and we have 2 of them. And this brings our grand total to be 18 valence electrons. So now that we know the number of valence electrons, we can go ahead and do our arrangement. We know sulfur is going to be in the middle, and our oxygen is going to be surrounding it. Let's go and connect them. We made 2 bonds, therefore we used 4 valence electrons. So we have 14 valence electrons left over. That means we're going to have 14 dots. Starting with our surroundings first, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And before we say this is our final answer, we have to see if all atoms follow our octet rule. Unfortunately, sulfur does not. That means we're going to have to make a new bond. We take one of these lone pairs on our oxygens to make a new bond. I'm going to go ahead and take this one. Again, doesn't matter which one you take. And I'm going to make a new bond. As a result, this goes away. And that is our Lewis dot structure for problem number 4. So now we can go ahead and figure out how many bonded atoms we have in our center. Yes, we have 3 bonds, but we only have 2 oxygens bonding to sulfur. Therefore, our bonded atom is 2. Lone pairs, we only look at our sulfur, and sulfur actually has 1 lone pair there. So, looking at our Vesper theory chart, finding the row that says 2 atoms and 1 lone pair, our molecular shape is going to be bent. And our electron geometry is going to be trigonoplanar. And that is your final answer. And that's it, guys. Thanks.